All right, 7.5 part 1. All right, 7.5 part 1 covers adding, subtracting, and multiplying radicals. So we'll start off really easy here. So the first example, we are going to simplify by combining radical terms. Simplify by combining radical terms. This part is very easy. So you know how we can add like 5x plus 2x is 7x, right? Those are like terms. It works the same for radicals. So for the first example, we're going to do 6 root 7 plus 4 root 7. So if I have 6 root 7s plus 4 more root 7s, how many root 7s do I have? 10 root 7. That's your answer. That's nice. So they have to be the same type of root. Like if it was a square root and a cube root, it doesn't work. It has to be the same number in the root and the same type of root. Same number in the root, same type of root. So let's look at another one. We're going to do 6 times the fifth root of 4x. 6 fifth root of 4x plus 3 fifth root of 4x minus the cube root of 4x. You can try it if you want. So on this one, it's the same thing in all the roots, right? 4x, 4x, 4x. Are they all the same type of root? No, they do not all have the same index, right? This one's a cube root, so he cannot combine with the other two. These two are both the fifth root of 4x, so we can combine them. It has to be the same type of root, same thing in the root. So what's 6 fifth roots of 4x plus 3 fifth roots of 4x? 9 fifth roots of 4x. It's annoying how long it takes to say that. 9 fifth roots of 4x. And then this poor guy out here, the minus cube root of 4x, he just has to stay by himself. Minus the cube root of 4x. Yeah, he's just a loner, which is fine. It's okay to do that. Yay! So those are the easy kinds. Let's get a little tougher. Maybe they give you something and say you have to add or subtract it, and none of them are the same, and you're like, I can't do it because none of them are the same root. No, you have to do it. So what if we had like 3 root 8 minus 5 root 2? 3 root 8 minus 5 root 2. So right now, these are both square roots, which is nice, but they have different things inside. One has a 2 and one has an 8. I know I can't simplify the 2 anymore, right? Because 2 is just 2 times 1. So what we want to do is see if we can simplify the 8, and maybe it'll turn into a root 2. Like, it would be really nice if it did, right? Because then I could combine them. Maybe it does. Let's see. So 8 is what? 2 and 4? And we can't break down 2. What's 4? 2 and 2. So does anyone get to come out? Yeah, one representative from this pair gets to come out. This guy has to stay in. So it is going to work. So when we write this out, make sure you don't forget about this 3. So I've got the 3 on the outside. Yeah, times the 2 that's coming out. That came from right there. This 2 is coming out. It came from this guy who's coming out. And then we have the root of what? 2, because this guy was staying in. So that guy came from there. Just so you can see where everything is coming from. Yeah? Mm-hmm. It wouldn't be, it'd just be y. Just be y coming out. So how can I rewrite this? What's 3 times 2 root 2? 6 root 2, right? This is 6 root 2, and then I'm doing minus 5 root 2. So once we simplified it, it became nice. It became the same root, so we could simplify it. What's 6 root 2 minus 5 root 2? Just 1 root 2 or just root 2? You don't have to put the 1. If you did put it, I wouldn't count it wrong, but you don't have to put it. So that's not too bad, right? You just simplify and then you can put them together. Let's do another one. Ready? With more variables. With variables. That one didn't even have any variables. We're going to do the cube root of 2x to the 6th, y to the 4th, plus 7 cube root 2y. Alright, which one of these can I not do anything to the root part of it? Which one of these is not simplifiable? The second one, right? 2 doesn't break it anything, y is not going to be able to come out. But maybe we could simplify this one, because we're hoping we would get a 2y in here then. So I don't think the cube root of 2 is going to do anything. What about the cube root of x to the 6th? That's, yeah, so let me, maybe for some people it would be helpful if I wrote this in 3 parts. This is a cube root of 2 times the cube root of x to the 6th times the cube root of y to the 4th. Okay, so I just broke this first one up into 3 separate things. We already decided this one we can't change, but yeah, what'd you guys say this is? What's the cube root of x to the 6th? X squared. It's just x squared, right? Because this is x to the 6th over 3, numerator, denominator, which is x squared. And then what about this last one? We've got y to the 4th. We're looking for groups of 3. So how many groups of 3 get to come out? 1 group of 3 fits in it. And then how many are staying inside the root? 1 was left over to get us up to 4, right? Yeah? Oh, there we go. And then the cube root of 2 is staying the same. All right, so we got some stuff to come out of this one. You might have been able to do this without doing that. Avery and Piper, you need to stop talking to each other, okay? You're not going to sit by each other anymore after this week, probably, just so you know. All right, so on this one, the x squared is coming out. A y is coming out. We dealt with him, we dealt with him. On the inside of the cube root is a 2 and a y. Those guys are still stuck in the root. So now we've got x squared y times the cube root of 2y, and we're still adding it to 7 times the cube root of 2y. So we just simplified that first one, and luckily it became the same exact root as what was in the second one. So now when we add this together, it's kind of weird because the x squared y and 7, like we can't just make it a number. So you guys have to write it like this, x squared y plus 7, and put it in parentheses, because we're adding this and this, times the cube root of 2y. Yeah? Then, so if I told you to add them and you couldn't make it the same, I would say you're either doing something wrong, like you're probably doing something wrong because I won't give you one where you can't do it. Yeah, so like if you're doing your homework and you're like, these won't become the same, then go back and look back at it because they should become the same. Okay, I want you guys to try one real quick. 3 root x plus the square root of 25x to the 3. Try that one on your own. Oh, hi. Oh, here, let me pause it really quick.
Hello everyone, this is Carson. I will now be doing the math problem. So, what you have to do is you gotta simplify this to get your 5s, as shown. And your x's, you take 2 out and 1 stays in. So then you have you get that once you simplify that, and then you just add them together to get that. And that is your answer.
When there's a next one, someone else can do it. Yeah. You said you didn't want to do it, Jack. Good job. Okay, maybe we'll draw numbers. Alright, so we talked about adding and subtracting, now we're going to do multiplying. So for our first example, we're going to do the square root of 3 times x minus the square root of 5. So now we're kind of changing gears. We were adding and subtracting, now we are multiplying. For multiplying, they do not have to be the same type of root. We can multiply whatever we want. So on this one, we're going to have to distribute, right? So we're going to have to do root 3 times x. So the way we write that is we like to write the things that are not in a root first. So we're just going to write that as x root 3. Because we write the things that are not in the square root first. So it's x root 3. And then we're going to have to do root 3 times root 5, or negative root 5. So positive times negative is negative. What's root 3 times root 5? Root 15. That's it. You'd want to make sure you couldn't simplify that. And I know that 15 just breaks into 3 and 5, and that's it, so I can't simplify it. That's it. Alright, next one. Let's get harder. Next one is the cube root of y times the cube root of y squared plus the cube root of 2. So you can only put things in the same root when you're multiplying them if they're the same type of root. If they're not the same type of root, you'd have to like work with exponents and then multiply them. Like work with fraction exponents. So this one, since they're both cube roots, we can go ahead and multiply that. What's the cube root of y times the cube root of y squared? It's the cube root of, yeah, cube root of y cubed. Because y times y squared is y cubed. And we'll simplify that in just a second. Let's multiply it first. And then we're going to do, what's the cube root of y times the cube root of 2? Yeah, the cube root of 2y. So we're just multiplying these things and keeping them in a cube root. And then I think you guys were saying one of those could be simplified. Which one, red or green? Red. The red. So what happens to the cube root of y cubed? Yeah, it's just y. So this is just y plus the cube root of 2y. That's it. 1, 2, 3 more examples. So here we're going to multiply 4 minus root 7 squared. Okay, now this one is really going to be really important for tomorrow because tomorrow is going to get way tougher. So this one is very important for tomorrow. So when we do this, does this mean that I get to do, oh, let's see, 4 squared is 16, and square root of 7 squared is 7. Yeah, there's a minus and it messes everything up, so we don't get to do that. So this means that we've got to do 4 minus root 7 times 4 minus root 7. Squared means this multiplied by itself. So we could use our, this is a perfect square trinomial, right? We could use that shortcut. For now, let's go ahead and just really multiply it to make sure you guys see what's happening here. So we got a FOIL, right? We need to make sure the 4 gets multiplied to both of those guys. And then the square root of 7 has to get multiplied to both of those guys. You have to be fair. Everything's got to get multiplied. So let's do 4 times 4. What's that? 16. And then what's 4 times negative root 7? Negative 4 root 7, right? You just stick the number next to the root, and it's negative because positive times negative is negative. Now we're going to do, what's negative root 7? So we did the 4 to both of those guys. Now we have to do the negative root 7 to both. So what's negative root 7 times 4? Minus 4 root 7. And then we've got to do the negative root 7 times negative root 7. What's negative times negative? What's root 7 times root 7? 7. Right? Because that's the square root of 49, which is just 7. Now I think we can simplify some of this, right? Does the 16 have any friends to combine with? Yeah, the 7. They're both constants. What's 16 plus 7? 23. And then does the negative 4 root 7, can he combine with any friends? Yeah, this one has a square root of 7 too. What's negative 4 root 7 minus 4 root 7? Negative 8 root 7, right? Because we just combined negative 4 minus 4 is negative 8. And then the root 7 stays the same. It's kind of like if it were an x. Yeah? Right, but we are adding them right now because we're combining like terms. We were multiplying, now we're adding them. Good. Okay, 2 more. 4 root 3 plus root 2 times root 3 minus 5 root 2. Do you guys want to try it or do it together? Do it together. No, wait, there is one more try. There's a try one coming up. Sorry, I lied. There were actually 3 more examples still. So we'll do this one together, one more together, and then there's a try. One of you guys can do it. So I know some of your guys' YouTube names because you guys follow me. I see you guys on there. Well, you guys follow me. I get an email and it says so and so followed you. I was like, and then I usually try and guess who it is. I'm like, I'm guessing that's this person. I should what? Oh, really? I remember last year someone subscribed when you guys were 7th graders and I watched the video and it was just like a video of someone playing a video game. And then my husband was like, oh yeah, people do that all the time. And I was like, okay. I guess that's the thing you do. You watch other people play video games. No, it's not. That's not the same. That's like learning about yesterday these videos of people playing with slime. It's so bizarre. This is great. All right, let's multiply. All right, let's multiply and let's try to take some shortcuts along the way. So we're doing 4 root 3 times root 3. What is root 3 times root 3? It's just 3. So we're really just doing 4 times 3. 12, right? Here, let me do that in one more step. Sorry. Okay, let me do it in 2 steps. 4 root 3 times root 3 is 4 root 9, right? Right? And then the square root of 9 is 3, so this is just 4 times 3, which is 12. Yeah? Well, I mean, it's kind of like if you do 3x plus 2x, you don't change the x, right? Because we're just adding up how many we have. We don't change them. But if we're multiplying 3x times 2x, that's 6x squared. So if you're multiplying, it changes what you have there. So now let's do 4 root 3 times negative 5 root 2. Okay, so what's 4 times negative 5? Negative 20. And then what's root 3 times root 2? Root 6, right? Because if we're multiplying, we multiply what's in the roots. All right? Now, we did the root 4 root 3 to both. Now we have to do the root 2 to both. What's root 2 times root 3? Yep, plus root 6. And then what's root 2 times negative 5 root 2. It would be negative 5 root 4. And then what's the square root of 4? 2. So it's just negative 5 times 2, which is negative 10. I don't think this is our answer yet, right? Yeah, because, like, who is 12 friends with? The minus 10. So what's 12 minus 10? 2. And then does negative 20 root 6 have any friends? Yeah, plus 1 root 6. What's negative 20 root 6 plus 1 root 6? Negative 19 root 6. Good. Okay, one more together and then we'll do a try. It's not bad. Square root of A plus square root of B times square root of A minus square root of B. What is this an example of? A difference of squares, right? This is the factored form of a difference of squares. We'll multiply it all out just to remind you guys what happens. All right, so let's multiply it out. What's root A times root A? The root of A squared, which is A. Because you can think of it like this first. It's the root of A squared, which is just A. What's root A times negative root B? Negative root AB. Positive times negative is negative, and then we just have A and B multiplied together in the root. Now we need to multiply the root B to both. So what's root B times root A? Positive root, I'm going to write AB. You could write BA, but I like to write in alphabetical order. AB. And then what is positive root B times negative root B? It would be negative, and then it's the square root of B squared, right? Which is just B. So remember, the square root of, like, x times the square root of x is just x. It goes away. Yeah, it's just a minus b. Negative root ab plus root ab is 0, so it's just a minus b. It's nice because all the roots went away. Maybe tomorrow we'll have to rationalize denominators using that trick. Maybe it'll work to help us somehow. Okay, one more try. You guys try this one. Okay, so, okay, there we go. So, what you're gonna do is you're gonna want to, like, how do I say it, spread it out, because since there's an addition sign in the parentheses, that's, like, not cool, you can't do that, so you're gonna go 7 times the square root x, and then you're gonna have another one, 7 plus square root of x, and then you're going to, so you're gonna do 7 times 7, which is 49, and then you're going to do, 7, then you do 7 times x, root x, so then you're gonna get 7 root x, and then you're going to do, plus, and then you're going to do root x, 7, and that's going to be another plus 7 root x, root x, and then you're going to do root x times root x, which is, oh no, x, because x squared is, x squared cancels each other out, so you just have x. And so now you're going to combine like terms. So 49 is all alone. Can't combine anything with that.
then you're gonna do plus 7x plus 7 root x and plus 7 root x, which is 14 root x plus, and then nothing combined with x, so it's just x. And that is the answer.
Alright, if you were here today, you need to do page 466, number 9 through 16, multiples of 3.